Good evening, everyone. Today, our topic is multiphase chopper. So, what is multiphase chopper? So, multi means multiple. That means two or more than chopper is connected in parallel. Then we can call it as multiphase chopper. So, if two chopper is connected, then it will be two phase chopper. If three chopper is connected in parallel, then it can be called as three phase chopper. Now, this is a common two phase chopper circuit diagram. So, what is the form? See, here this is the two choppers CH1 and CH2. Both choppers are connected in parallel, and here two inductor that is connected in series with these two respective choppers, and the value of the inductance of these inductors is sufficient large that the both chopper can work independently. This is the load connected in the circuit, and these are the two freewheeling diodes. Now, for multiphase chopper operations, there is two modes. One is in phase operations and another is phase shifted operations. So, what is in phase operations? In phase operations means here the different choppers are working at the same instant, and when we are continuing discussing with the phase shifted operations, there the different choppers will work at the different instant of time. So in this two mode we can work with the multi-phase chopper. Now firstly we discuss about the in phase operations. Here the duty cycle alpha is 30%. That means this is the conducting time. That means the total 30% of the time period T, the choppers is going to be conducted. As it is in phase operations, we earlier discussed that for in phase operations the different choppers will do their functions at the same instant. So here, as per the circuit diagram, the input current I is flowing, and that is I1 and I2 that is flowing through the chopper circuit, and here the output current through the load, that is I0. Now if we do a common waveform, then what will be the waveform for input currents? See, that is the I1 is the input currents for the chopper 1, and I2 is the input currents for chopper 2. So as the both chopper is going to function at same instant, as it is a in phase operation, so the waveform is like this. That is, this is the T on means this is the conducting time period of chopper, and this is the T off, that means the non-conducting time period of chopper. That means this is T off and this is T on. As it is alpha is 30%, that means the chopper is conducting in the 30% of the total time period, and the 70% time it is going to be non-conducting mode. So this is T on, this is T off, then again the chopper 1 is going to be conducting, that is T on and that is T off. So this is the I1, that means the input current waveform of the chopper 1. Now as it is a in phase operations, that means two choppers, that means chopper 1 and chopper 2 is going to work at the same instant. So the I2 current waveform will be similar to the I1 current waveform. So that is also here this is T on, this is T off, and so like that. So that means as it is a in phase operations, the both chopper is function at the same instant, so we get the similar current waveform for the both chopper. Now if we do the total input current waveforms, then what will happen? See, that is going to be I1 plus I2. because these, as per the circuit, these two currents I1 and I2, the total summations of I1 and I2 is represented the total inputs current I, and as the both chopper is connected in same instant, so obviously the input currents is going to be doubled up. So these I0, the both magnitude is going to summed up, and the actual value of the input current, that is going to be doubled up, so that is 2I0. So this is the total input currents waveform, that is going to be 2I0, as it is going to additive. Now when we are considering the same circuit for the phase shifted operations, then what will happen? See, for phase shifted operations, this is the waveforms. Now here for phase shifted operations, we see that the different choppers are functioning at different instants. That means when the chopper 1 is going to in conducting mode, then obviously chopper 2 cannot conduct as it is designed. Now suppose the chopper 1 is going to conduct first. So as we considering that here again duty cycle is 30%, that means suppose chopper 1 is going to conduct from t equal to 0 to 0.3 t, because t is the total time period, so 30% conduction means 0.3 t time. So t0 to 0.3 t, this is the conducting time period for chopper 1. So as per that, the current waveform for chopper 1 is this. The input current waveform for chopper 1 is going to behave like this. Now when after the conducting mode over for the chopper 1, then chopper 2 is going to go to the conducting mode. As it is a phase shifted operation, that means the different chopper is going to conduct at different instant. Now here this is the non-conducting time period for chopper 1, and in this time period, in between this time period, chopper 2 is going to in conducting mode. So this is the waveform, current waveform, input current waveform of chopper 2. So now this is chopper 2. So this is the chopper 2 current. Now see, when chopper 1 is going to in conducting mode, chopper 2 is off. Then chopper 1 is now non-conducting mode, chopper 2 is conducting mode. Again in the next cycle, chopper 1 again going to conducting mode, then chopper 2 is in non-conducting mode. Then chopper 1 is going to non-conducting mode, chopper 2 again going to in conducting mode. That means the phase shifted operations, that means the two chopper is going to functioning at different instant. So for this reason it is called as phase shifted operations. Now again like the previous one, again if we going to draw the total input current waveform I, because this is the input current for chopper 1, this is the input current for chopper 2. Now the chopper 2 is connected in such a way that the total input current waveform will be a periodic nature. Now the total chopper current waveform, the total chopper input current waveform will be here. See, if we do the summarizations of 2, then what will happen? This is T on, again T on, again T on, again T on. So that means here this is in conducting mode. The chopper total circuit is now again in conducting mode. Now this is in conducting mode. Then for this again that is in conducting mode. That means you see that the total waveform, if we considering the total waveform, here the duty cycle is 30%. Now for the both operations, that is for in phase operations and phase shifted operations, for the both operations the same circuit is functioning for the duty cycle alpha equal to 30%. Now when we considering the total current waveform, total input current waveform for in phase operations, he see here the frequency of this waveform, And now the same circuit is going to functioning for phase shifted operations. Now for the phase shifted operations, again you can see the input current waveform. What is the difference between these two waveforms? It is obvious that here the frequency, the input current frequency is going to be doubled up. The frequency is going to be doubled up here. So as the input current frequency is going to be doubled up, that means the size of the filter circuit for this type of chopper is going to be less. And for this reason, the phase shifted operations of chopper, the phase shifted choppers operations is very much preferred. Now if we again I tell that if we considering the comparison between these two current waveform, see here, so frequency means what? That is the rate of occurrence in a particular time period. Suppose this is the total time period, so this is the rate of occurrence here for the current waveform. And now for the same circuit, when we go for the phase shifted operations, then the total time period, the rate of occurrence going to be doubled. So why it is going to be doubled? Because here the two choppers is going to functioning at different instants. So when the chopper 1, this is in conducting mode, for that we can get this waveform. Now when chopper 1 going to in non-conducting mode, then chopper 2 is going to conducting mode. So again in this instant we again get this conducting current waveform. So the total frequency is going to be doubled up with comparison to the in phase operations. So from this part, what is the summarizations? That is, the multiphase chopper is the chopper that is when two or more choppers is connected in parallel. And multiphase chopper, there is two modes of operations. One is in phase operations, number two is phase shifted operations. So in phase operations, the phenomena is there, the total input current waveform, the input current is going to be doubled up as the two choppers is working at the same instant. And when we are considering the phase shifted operations, there the two choppers is working at the different instant, but the input current waveform frequency is going to be doubled. And for this reason, the filter circuit for the phase shifted operations of chopper is going to be less sized, and for that reason the phase shifted operations of chopper is preferred. Thank you.